Today we are officially starting Chapter 4. Our objective for today is to classify triangles by sides and angles. Alright, for this lesson we've got a lot of vocab words. Most of these we're going to go through and look at diagrams of them later in the notes, so I'm not going to read off all of these. You should have already read them when you wrote them. The ones we will talk about real quick: triangle. I expect you knew what that meant before you ever walked into this classroom. It's a three-sided polygon or a figure formed by three segments joining three non-collinear points. It's a more technical definition of it. The other ones we're all about to go through with diagrams, but the very last one, a vertex, if that definition's too technical, you can think about it as a corner of the triangle. Okay, there are three vertices. That's the plural of vertex. Three vertices, or corners, points. That's where the angles are. Okay. These diagrams show us how to classify a triangle by its sides. So we will be classifying triangles by sides and by angles. There are three ways we can classify a triangle by sides. Equilateral, meaning that all the sides are the same or all of them are equal. Isosceles, meaning we have two congruent sides. And scalene, meaning that we do not have any congruent sides. Alright, these examples should go quick. Probably the longest part is going to be copying the diagrams into your notes. So I'll give you a moment to do that before we talk about the answers. Let's go through these. We are classifying the triangle by its sides. So we have three options: equilateral, isosceles, and scalene. Who can raise their hand and help me out with this first problem? 1A. Honesty? Scalene. All the sides are different, so we would call it scalene. Ooh. Yes, I want you to write it out. Don't just put an S. If you do that in your notes, I'm not really going to stop you, as long as when it comes time to the notes quiz, you know what you're talking about. But on a quiz or test or homework, I expect you to write out the words. All right, letter B, Jaden. That is equilateral. All of the sides are the same. So we call it equilateral. And letter C, Angel, is isosceles. Two of the sides are the same. All right, who can help me out with this first example on number 2? Shelby? That is also isosceles. Two of the sides are the same. One of them is different. The second one from example 2. John? Equilateral. They're all the same. All congruent. Equilateral. What about this third one? IKEA? Scalene. They're all different. And finally, number 4 from example 2. The last one on example 2. David? Also scalene. Also 3 different sides. Wonderful. Again, this can either go on your vocab sheet or it can go in that box on the back side of your notes handout, wherever you would prefer to put it. To classify a triangle by its angles, we have 4 options. I'll give you a moment to write those down before we talk about them. All right, these are things you probably already knew also, but we'll review them real quick. An equiangular triangle has 3 congruent angles. All the angles are equal. An acute triangle has 3 acute angles. All 3 of them must be acute. Who can remind me what the word acute means? Less than what? 90. Less than 90 degrees. So all 3 angles have to be less than 90 for it to be acute. The different one is obtuse. For it to be obtuse, you just need 1 angle to be obtuse. Obtuse meaning not 180. It has to be bigger than what number? 90. Bigger than 90 and less than 180. So 1 angle in this diagram, it looks like it's the top right angle that would fall under that specification. 1 obtuse angle. And then for a right triangle, you would only have 1 right angle. All right, 3A. Who can raise their hand and tell me how we would classify that triangle by its angles? Jordan. That is a right triangle. If you have a right angle, it is absolutely a right triangle. All right, 3B. I need new volunteers. I've still got several people I haven't heard from yet today. Connor.
I'm not attached to this. That one.
Now I believe we agreed that letter B is equiangular. All of the angles are congruent. Later, we will either learn it or hopefully we'll pick up on it at some point. But if you have an equiangular triangle, they're all going to be 60 degrees. So if they're all 60, it's equiangular. If it's equiangular, they all have to be 60. We'll talk more about why that's the case later this chapter. But for it to be equiangular, either they're all going to be marked with 1 arc like they were in the diagrams above, or they're all going to be labeled as 60.
What's the difference between equal and
Why did you choose obtuse?
Because I did the math and I added up to 180.
Ah, interesting. That is not the definition of obtuse. Because if that were the case, B would have been obtuse also. 60 plus 60 plus 60 is also 180. So I would disagree with obtuse. Nikitra. Acute. Why? The biggest one we have is 85. All 3 of these angles are less than 90. That makes it acute.
So what would have made it obtuse?
If 1 angle is greater than 90, it's obtuse. What if what's bigger than 90?
What if what is it called? Degrees?
An angle?
Yeah, what if it's bigger than 90?
That's what makes it obtuse. If 1 angle is bigger than 90, it's obtuse. I need somebody new to help me out with the first one on example 4. I would agree that this one is equiangular. All right, what about the second one? Somebody raise their hand and help me out. Cade. Obtuse. There is 1 angle that's bigger than 90, 1 obtuse angle. That makes the whole triangle classified as obtuse. And on number 7. Jakai, what do you think? Acute, I would agree. All the angles are acute angles, making the triangle acute. All right, on example 5, we are naming the side that is opposite the angle. The easiest way to describe that, if the word opposite doesn't make a whole lot of sense to you in this situation, would be the side that doesn't make that angle. So the side opposite J, what side has nothing to do with angle J? LK, the one opposite of it or across from it, LK would be considered the side opposite angle J. When we go to answer these questions, that is side LK, it is a segment, so we use the segment designation with just a line over the top, not arrows on either end. And we also have to have that little segment bar above it. If you just put LK without the bar above it, it is not correct. All right, now that we have a better idea of what it means to be opposite an angle, who can raise their hand and tell me which side is opposite angle K? Somebody I have not heard from yet today. Julian. I believe that's an L, but yes, from here it could look like an I. LJ is correct. And for the last one, we need the side that is opposite angle L. No new volunteers. Brandon? Side KJ is correct. All right, that is it for today's note.